universe. Once upon a timeless, most cosmologists believe all that is our universe was incredibly small and dense. Neither space nor time as we know then existed. Nothing is known of this earliest instant. Scientists use the term Big Bang, see one, that is a Big Bang, to describe this moment of creation. Somehow the universe, all matter, energy, space, and time exploded from the original singularity. Because time did not yet exist, there is no way to measure this event, but scientists have agreed to start the universal clock at Planck time, that is 2. A moment defined as 10 to the power minus 43 second, which is a decimal point followed by 42 zeros and a 1. Named after the father of quantum physics, Planck time, is the point at which the universe begins to differentiate. Gravity, 3, this is gravity, becomes a separate force, tearing away from the other, still unified basic forces of nature. Then let's take 4. Look at this area. 4. Now what is 4? Separation of the strong force 10 to the power minus 36 second. Although atoms do not yet exist, the force that will hold their nuclei together becomes an individual entity. 5. Where's 5? Here. This is 5. Okay. 5. Inflation 10 to the power minus 36 to 10 to the power minus 32 second. Triggered by the separation of the strong force, the universe expands more in this instant than it has in the roughly 15 billion years since. 6. You have this quarks, QARKs, and antiquarks 10 to the power minus 32 to 10 to the power minus 5 second. As inflation ends, the still expanding universe now teems with quarks and antiquarks, the smallest known constituents of matter. So this is it. The smallest known constituents of matter, along with electrons, L in the illustration, and exotic particles W and Z. Quarks and antiquark annihilate each other upon contact, but a surplus of quarks, 1 per billion pairs, survive. This surplus of quarks will ultimately combine to form matter. Then we come to 7. Look at this. Okay. At 10 to the power minus 12 second, the final 2 forces split off. Electromagnetism, 7. The attraction of negatively and positively charged particles is carried by photons, the basic units of electromagnetic energy. The weak force, this is it. The weak force controls certain forms of radioactive decay. Then let's come to 9. This is the 9th one. So 9. Look at this. 9. Quark confinement 10 raised to the minus 5 second. As the universe cools to 1 trillion K trios of quarks form protons and neutrons. 10. Look at this. Nucleosynthesis less than 1 second to 3 minutes. Cooling continues. Protons and neutrons bind to form the nuclei to soon to be formed atoms. 11. Look at this, 11. So that's, what are we doing? The short history of the universe. So energy domination, 10 raised to power minus 32 second to 3000 years. Because of high temperatures, radiant energy generates most of the gravity in the universe during this period. Let's take 12. Now what is 12? Matter domination, 3000 years onwards. With cooling, matter becomes the primary source of gravity. Matter begins to clump and form structures. In theory, particles of so-called dark matter, depicted as grey bubbles, would have come into existence by this time. They may account for as much as 99% of all matter. So, that is 12 as we said. Then you have what is 13. This pink part. Right up till down. So 13. Decoupling 300,000 years. Continued expansion and cooling allow matter and electromagnetic energy to go their separate ways. Nuclei capture electrons to form complete atoms of hydrogen, helium and lithium. The universe becomes transparent. Radiant energy of photons travel freely. These photons now exist throughout the universe. As microwave radiation. They reveal ripple-like concentrations of primordial matter, seeds for the structure of the universe that arose during the era of inflation. The ripples are shown in a 1992 COBE satellite image. This is what it is. Here you can see these. Then you have the 15 galaxy. So what is a galaxy formation? 200 million years onwards, matter continues to clump in the areas of concentration, and over eons is condensed by gravity. This gives rise to quasars. 16. Look at this. Pictured in a radio image emitting bursts of energy and galaxies. So we have 18, 19. This is you have 17 galaxies here. So you have 18, 19 is continued expansion of the universe. Galaxies cluster in an overall structure of sheets separated by huge voids containing relatively few galaxies. So that is a story of a short history of the universe. Isn't it interesting? Found it in an old National Geographic volume that I have, January 1994. Very interesting.